going to start by going over the homework. Okay, so let me go and pull that up. So here's my solution to city-state. All right. So I grabbed the entire entry. So each row, right, contains the city and the state. I've seen some solutions where you have two separate variables or like two separate fields in an array to store the city and the state separately. You can do it that way too, but I chose to do it with the city and the state all stored within the same string. Uh, the most relevant part of the string is the beginning and the end part, right? So I get those, and I use that as a key to map into the map. Sorry, to put into the map, and then after that, I also do a check to see like if we do the reverse, are there any entries that have that those two things reversed. So here I did a hash map of actually strings to integer. So here we map the first two and the last two letters of the city state to the frequency count. So that way, so yeah, I don't actually need to store the entire list of strings that the state maps to. All right, any questions on this?
Is there a certain function you can use with to get like get the certain key? Like if I were to give in like a value, it could tell me what key it's from. I mean the same thing the opposite way. I can give
There
a
is, and well, you can do it yourself, but if you find yourself needing to do that, you are kind of defeating the purpose of using a hash map, because that search is going to run in big O of n. Right, it's efficient at retrieving the keys, but right, the key to
yeah.
value mapping, that's dependent on you actually knowing what the key is. So if you want to search through the values, right, to find a key that has a corresponding value that's matching what you want, this is what you do. So you so you have a target here, and then you can say for key in map.key sets, if if map.get of key equals target, then then that's your thing. But it runs in big O of n. So if you find yourself doing that, there might be instances when you want to do that, but this is not ideal. If you find yourself doing that, you're probably not using a hash map the right way.
Then how should we use it instead?
Well, however works for you. So it's the 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 idea of using a hash map is having the lookup from map to value very efficiently, right? So maybe you should consider what you want to actually put as the key and what you want to put as the value.
I see. And then you just so you're just looking for does this part of the map contain this key, and you're trying to find that.
Correct. Yeah. So it's efficient at finding whether it has a key and if it is what the corresponding value is. Right. So that's how the hash map works.
Okay.
Okay.
All right.
So what I want to go over today is something called hashing theory. You're not going to use it too often in the silver level, but I think it's still worth talking about. So yesterday, I talked about how with a hash set or hash map, it's very efficient at figuring out whether an element is contained in the set. Uh, or in the case of map, the key set, right? So how does it actually work? It uses something called a hashing function, and I don't want to explain what that is just yet, but I do want to kind of demonstrate the math behind it first. So I'm just going to create a class file, a lesson 13 file. All right. So what I need from you guys is two prime numbers. Okay, so two-digit prime numbers. Okay, so just if you have prime numbers that's memorized off the top of your head, just say it. Okay, I need two random two-digit prime numbers.
The
Anybody?
20 and 97.
97 is the second one. What's the first one?
23.
23. Okay, so all right. So let's say I have two prime numbers, 23 and 97. Okay, so what I want to demonstrate here is a pseudo random generator, pseudo random number generator. All right. Um, so I'm going to do this. I'm going to do for int I equals 0, I less than q, I plus plus. So it's going to loop q times. It's going to loop 97 times. And I am going to do p times I mod q. Actually, I don't really need the parentheses, but whatever. That should be a mod. Okay, so you can run this in your Eclipse workspace, or you can just look in my screen share, and I will be running it in my workspace. Either way is fine. Let me go and pull up my project. Oh, Venkit, by the way, Ben just fixed your VM, so if you try logging in again, it should work.
Okay.
All right. So I'm gonna run it, and it spits out a bunch of numbers, and let me paste those in the pad as well, just so you can see a bit more clearly. So these are the numbers that it spits out. Okay. So there's 97 of them. One thing to note is if you look hard enough, these numbers are all totally unique. Okay. So it's something modulo 97, right? So that number that we're printing out, it has to be a number between 0 to 96, and all of them are unique. Okay. Um, And if you know something about modular arithmetic, this might not surprise you, but even if you don't, you can just kind of take this as face value. This thing works as long as these two numbers are relatively prime. Um, right. And if you look at this list of numbers, they look seemingly random. Well, it's not random in the sense that, like, if you look at the formula, that there's definitely a pattern to it, right? There's a formula, right? I've written it out right here. But at a cursory glance at it, right, it does look seemingly random. So sometimes we call this a pseudo random number generator. Okay. So what I can do is I can use this to make a function that takes in an input, and it's going to give us back a semi-random output. Not random in the sense that when you call it with the same input, it's going to return you with the exact same output. So in that sense, that's not random at all. But the number that it spits out, it's going to be a number between 0 to 96. So if you think of this formula as like I being the variable here, where p and q are constant. So you can think of I as the input to this formula here, and it would give you back a somewhat random number from 0 to 96, right? And that's something called a hashing function. And it's really useful when we're doing hash sets. Okay, so how does a hash set work? What is it that makes it able to very efficiently look up whether something exists in the set or not? So I said last time, right? Hash set is very efficient at the following operations, right? The add, the remove operation, and the contains operation. Um, and the contains function in particular, it really doesn't need to loop through each and every single element in the hash set in order to figure out whether an element exists in the array or not. With an array list, we need to do that. With a hash set, we really don't need to do that. So how does it work? Let's go ahead and try to implement a toy hash set on our own. So I'm going to create a class here, int class, sorry, static class. I'm going to call it int set. Okay. So it's for simplicity, it's going to only be able to take in integers. Okay. So the underlying data structure that we use to back a set, a hash set, is actually still an array. Okay. So I'm gonna actually create these two numbers here again, and I'm also gonna create an array, an int array of length 97, of length q here. And I'm going to try to create an add function. Okay. So this int set here, it's got an add function. So you add an element into this set, right? So you take in an int element here. Now the question is, where do we actually put this element? We put it somewhere in the array, but at what index? There's a pattern to it, and we use a hashing function to do that. Okay. So I'm going to create another function. I'm going to call it int hash. Okay. So it's a function that takes in an element and it gives you back an integer. Right. And it's going to be the same formula. It's just this thing here, except we use x instead of I. Okay. So the hash is going to figure out, it's going to return a number between 0 to 96, right? Because it's modulo 97. Okay. And we use that as the index in the add function as to like where we store the element. Okay. So I'm going to do int index equals hash of element. Okay. And then I'm going to say array of index. Go and set it to element. All right. Okay. Yeah. So where we put the elements in the internal array is kind of bizarre. We use this hash thing. So let's go ahead and play around with this thing. Okay, so I'm going to go back to the main. I'm going to create an int set. I'm going to add a few random numbers here. Okay, so I'm going to do set.add 15. Okay, set.add 22. Set.add 76. Okay. All right. And then afterwards, I want to see like where these three numbers get stored inside the int set. So let me do system.out.println set dot array. Actually, with an array, to print out an array, I need to do arrays.toString on it. So let me go and do that. And I do need to import java.util.star to get the arrays thing. Okay, so I'm going to run this. So you can run this in your workspace, or you can Just watch me run it either way. Error here. Oh, close parentheses. Oops. Right, so let's go and run that. So here's the array that it printed out. I'm going to paste it back here as well. So it did in fact put those three numbers inside the array at semi-random positions, right? So 76 is here, 22 is here, 15 is here. Okay. So why put it in those seemingly random positions? Because when we try to implement the contains function, right? So a hash set, right? It's able to tell you whether the hash set contains an element or not. So we're going to try to simulate that as well. So it's a function that returns a boolean. So boolean contains int element, right? So it's going to return whether it contains this element or not. So how we determine that? Well, since in order for the set to contain the element, we have to have added it first at some point, right? We would have had to call the add function. And where do we add the element? Well, at the index determined by the hash function, right? So we want to go look at whether the element exists, whether the hash that contains the element. We just look at the exact same place, right? We calculate the hash and use that as the index, right? And then we check whether array of index is equal to the element. Okay. Right. So now that I have that, I'm going to go back to the main, and I'm going to do system.out.println set.contains 22, and it's going to tell me true. And if I give it a number that's not in the set, it should tell me false, right? So for example, dot contains 50, that should be false, right? Yeah, and that's exactly what happened. So there's something really powerful about this hashing thing, right? It allows us to put an element in a seemingly random position in the array, and because of that, in the contains function, we don't actually have to loop through the entire array to find like where that element is. We just need to look at that very specific index to see whether that element exists in the set or not.
Yeah, but what happens when you run out of space in it, though?
Yeah, so there's a couple of considerations. So this is a toy example. It is not perfect. In particular, right, what happens when you run out of space? And the other, if you try to do set.contains 0, it's going to give you a false positive. It's going to say it contains 0 even though it doesn't, right? Because all the entries here are 0. So there's something problematic with this implementation, but it does give you an idea as to how hashing works. So what are the problems here? So problems. Set.contains 0 returns true when it shouldn't. And there's the other thing called collision. So a collision happens when two elements have the same hash. Okay, so if you want to store two elements with the exact same hash, then you're in trouble, right? Because the hash determines where to store it, right? In the array, and you can't store more than one value in a position in an array, right? Yeah. So with this implementation, like there are these problems, but we can get around with fixing it by doing this. So the solution would be to have the hash set not contain an int array, but an array list of integers. Array, an array of array list. So in the int set class, do this instead for the array.
How can we use set contains if we're using an array rather than a hash map?
An array also has .contains. It's just slow, but it has it.
So you're just gonna show this?
No. So what I'm doing here, right? So instead of using an int array, I'm saying
Yeah.
use an array list of integers. So why is that? It's because now it enables us to, because with an int array, right, each element stores how many integers?
Right.
One, right?
One.
Right.
One.
Each element is one integer. So, but if I change it to an array of array lists, each element can store how many integers?
Several.
As many as we want, right? Zero or more, right? So, but you can think of it as the array as like 97 buckets, right? To put things into, and if we use an int array, it's each of the buckets can hold just one integer. But if we change it to that instead, right? Each bucket can store any number of integers, right? As many as we need to fit into that bucket, right?
Right.
Yeah. So if we use that solution, that actually fixes these two problems, right? So we don't have to assume that the entries are all zeros to begin with, and in the event of a collision, so when collision happens, we store we can still store the colliding element into same position in the array, right?
Yeah.
Yep. Now, it does kind of degrade the performance, though, when a collision happens. But with enough collision, let's say you want to store 1,000 values into this set, and those 1,000 values, they all collide with each other. Then you're effectively stuffing all 1,000 numbers into the same bucket, and you've degraded the performance, because the idea of separate them into different buckets is so you can retrieve them efficiently. But since the bucket is an array list, right? So if you stuff all 1,000 elements into the same bucket, into the same array list, you're gonna have to do a linear search through those 1,000 elements, and that would degrade the performance.
Right.
But still, as long as collision is collisions are infrequent, then the hash map, then the hash set here is very efficient. Okay. Questions on this? All right. So why do you need to know this? Because when you use a hash set, you need to think about how it does the hash function. In particular, with hash set or hash map, be really careful if you're trying to store things that are not the default data types. Okay, so let's say I have another class. Okay, So actually, let me put this caveat down first, okay? So this is really important. Be careful when using hash sets on custom data types. So if you define a custom class, let's say static class point, okay? So the point class is supposed to represent a point on the 2D plane, okay? So I'm going to do, okay, so it's got two fields, x and y, and I'm going to create a constructor for it so that when you create an instance of that thing, you you just put in the values like that. Okay. Now let's go ahead and try something here. Okay, so I'm gonna go back to the main. I'm gonna create a hash set of points. I'm gonna call it I'm gonna call it p set. Okay, point set equals new hash set. Okay. So to put something in this set, I have to create a point first, right? So why don't I do like point p equals new point 1, 2, like this? Okay. All right, and I'm going to do pset dot add p. All right, so now I'm going to do system dot out dot println pset dot contains p. All right, and this shouldn't surprise you. It should say true. Okay. Right. Let's go and run it to verify that. Why is this giving me an error? Huh. Interesting. Oh, duplicate local variable p. Huh. Of course. All right. Fine. I'll call it points. All right. So here's my code, and if I run it, so all I did was I fixed a syntax error and I changed the name of this to point. So I run it, it's going to return true. No surprise here. I'm going to create another point. Okay, so point 2. Okay, equals new points 1 and 2 again. So they keep in mind that they happen to be. They're actually two completely different point instances, right? They just happen to have the same values, right? They happen to have the same x and y values. Let's do pset.add points. Okay. Actually, no. Let me do pset.add point 2. Remember what I said yesterday about like with a set, all the elements need to be unique. If you go ahead and try to do system.out.println pset.size here, very surprisingly, you're gonna get 2. Yep. So what's happening here? It doesn't even think that these 2 points are equal to each other. Okay. Let me comment this out. So I can probably come up with an even more dramatic example. I can do system.out.println pset.contains point 2. Okay, and this is going to be false. Okay, assuming I've this line commented it out. All right. So what's going on here? So the hash set is not capable of understanding that these 2 points actually have the same value. So in Java, first of all, you need to do one thing inside a class to define how you want to define equality of 2-point instances. So we have a class points here, and you must supply an equals function that takes in the object type. So the object type, for those of you who are not familiar, it's like the universal data type in Java. So you must provide this function, and it has to be spelled exactly as such. If you worry about not spelling it correctly, and sometimes that really can happen, the bad thing about this is it doesn't give you a compilation error. Like if you make the function called equal instead of equals, the compiler will happily accept that. So if you want to safeguard against that, what you can do is add this thing. It's called an annotation. So it would force the compiler to check that you're indeed trying to override the default behavior of the dot equals thing. And this is where you define how Java should consider whether this instance of the point is equal to another instance of points. Okay, so here you can assume that the object can be cast to a point, and then you can return whether the internal x value of this instance is equal to p dot x and the internal y value of this instance is equal to p dot y. Right? Yeah, so you need to define that at the very least for hash sets to work on it. There's one more function that you also need to do. It's called hash code. I forgot if hash code, the code is uppercase or lowercase. Let me copy this over. Oh, it's lowercase. So what does hash code do? Well, hash code returns the... No, actually, it's uppercase. Hash code is the thing that gets used by the hash set to determine the hash value of an instance of this object. So what are the rules with hash code? With hash code, two objects, or whether I should say two points instances that have equal values must return same hash code. On the other 2-point instances that have equal values, sorry, that have different values, it'd be nice if they return different hash code, but it doesn't have to be that way. Okay, so if 2-point instances have the exact same x and y values, they absolutely must return the same hash code. 2 points with different values, different x and y values, it'd be nice if they return different hash code. But like I said, right, there's some chance that these values can collide, right? Collisions can happen, and that's okay as long as you keep it to a minimum. The hash set is going to be efficient. So they should try to have different hash codes, but if once in a while they do have the same hash code, that's okay. So what would be a good hash code for a point class like this? Kind of depends on what problem you're doing. If the problem, if the user problem specify that the x and y values are in the range from 0 to 1,000, then you can actually do something like this: 1,000 times x plus y. So this is a good hash function for if we assume x and y are between 0 to 1,000. Okay, so now that we have this hash code thing, what we can do is go back and run this again. So after we have that hash code thing, this is going to say true instead of false, because now it properly calculates the hash code of this point, and it has the exact same hash code as the original point. And not only that, we also have the equals function to say that, okay, these 2 points, they're 2 different instances, but they have the same values. They have the same internal x and y values. Yep, so now it returns true. Questions on this?
Is this the hash map?
This is the hash set class, the internal
Okay.
hash set class. Yep.
All right, so yeah, okay. And it's much. This is the much more efficient method in opposed to using arrays.
Depending on what you're doing. Yeah.
Okay.
Right.
What would a case would be where arrays are more efficient?
Well, there are cases where like you need to use an array instead of hash map or a hash set. So for example, if you need to store an array with these numbers,
Yeah.
3, 1, 5, 6, 8, 9, 10. Not
Mhm.
only these numbers, but these numbers in that order. There isn't really a good way
Then it
for a
makes
hash
sense.
set to convey that.
So anything with an order means for array.
Usually, I don't want to say always, but usually, yes.
Okay. Unless there's a huge list, and then you could probably use like some sorting algorithm.
It really depends on what the problem is.
Okay.
You get the hang of it if you do this long enough.
All right.
Yep. Yeah. Okay. So my advice is if you find yourself needing a hash set on a custom data structure that you create, do be careful. Sometimes you can actually get away with not using the hash set on the point. So for example, another way to represent these points, and this is not the best representation, but it works. But I can do this. So I can use a hash as a string, and string is one of those internal data types that already has the hash code defined for us. So instead of storing a point in it, if we do like point dot x plus a space and then plus point dot y, right? We can also use that as our hash set, except the internal representation of those elements, right? They're not points anymore. They're like a stringified version of points. So this is going to be cheaper to do. It's also less efficient because first of all, you need to actually generate this string. And then calculating the hash code of a string, it requires us to loop through each character. Java internally does that when it tries to find the hash code of a string. So this is a bit less efficient, but depending on what you're doing, it's sufficient. So you can do it this way for a quick and dirty hash set, or if you really need to squeeze performance out of it, then you need to write your own hash code. Questions?
So the hash code can be made custom.
If you create a custom class, you can make your own custom hash code. Yes.
Okay.
All right. So I'm gonna pivot to a different topic now. So I want to actually, yeah. So if you want to save this as notes, go and do that because I'm gonna clear out the board. I want to talk about one last data structure. It's called priority queue. So remember what I talked about hash sets and tree sets? With actually, let's talk about tree set. What's the main difference between hash set and a tree set? Well, with a tree set, it self orders the elements inside it. Okay, and that's great if the problem calls for it. There's also one huge drawback. With a tree set, the elements must be unique. Okay, so depending on what you're doing, this may or may not be a problem. Um, There's another data structure that's somewhat similar to a tree set. It's called a priority queue. So a priority queue itself orders the elements just like with the tree set. Uh, the nice thing about a priority queue is elements may be elements can be duplicates. So they don't have to be unique. So I'm saying, okay, so why not always use a priority queue instead of tree set? Well, with the tree set, you get a window, you get to view. Yeah. Provides an easy way to view portions of the tree set. And what I mean by that is, for example, give me a subset of the tree set in the range from X to Y. So if you have a tree set of numbers, you can call a function inside tree set. It's called subset. And you give it a low bound and a high bound, and it gives you a snapshot. It gives you a window towards all the elements stored in it that's between the low bound and the high bound. So if it's like a tree set of elements, you can say, hey, give me a tree set, a subset of all the numbers between 0 to 100. It's able to do that for you. With a priority queue, you don't get that service. However, a priority queue provides easy way to view and remove the smallest element in it. Okay, so that's the primary difference. It provides an easy way to view, and remove the smallest element in it. I didn't talk about it explicitly, but both data structure, they have an easy way to add elements. And when you add an element, it again does the self-sorting by itself. The way a tree set works internally, it's fairly different from a priority queue. But I'm not going to talk about the internals. I'm just going to talk about how to use them. So knowing the internals is nice, but it is not strictly required to be able to use these data structures effectively. So when would you use a priority queue? Priority queue is useful when you need to iterate through a set of values in ascending order, and during the iterations, potentially be adding more values to iterate on. You see what I mean when I pull up this next problem here. So let me go ahead and put this user code problem here. It's called milk scheduling. All right, so spend a few minutes looking at this together.
When you said that you need to like add potential values to iterate on, are you saying like as you're iterating through it, you just add something and add something to it in the middle of the iteration and then iterate the
Yes,
value that you just added, or skip the
yes,
value?
that is exactly what I mean. Yes.
Right, you're gonna skip the value or iterate the value.
You could be iterating values, and then as you're doing that, you find out, okay, there's more values to be iterated on, and you put it inside the priority queue.
Oh, okay.
Yeah.
All right.
You see what I mean when you look at this problem. All right. How are we doing? Do we need more time? Okay. Okay. So let's do this together. So there's like basically like a you can almost think of it as like a dependency tree, where like there's cows that are available for milking, and they take time to be milked, and as a cow finishes, right, that could free up other cows to be milked, right? Because there's like a structure of dependency here, where some cows it requires other cows to be milked first it's able to um, before it's able to what should we call it before it's able to be milked themselves. Okay, so I'm going to start out with the with parsing the inputs first. Okay, so the first row it's two numbers n and m. Being the number of cows and m being the number of constraints. Okay. All right. Let's loop through the next n lines. The next n lines denotes the time it takes for each of those cows to be milked. Okay. So I'm going to call it milk time. So milk time of I denotes time it takes cow I to be milked. All right. And then that's pretty standard. I just need to be doing this. Okay. All right. The dependencies, though, that is going to be a bit trickier. Okay. So we have M dependencies, and they're written in such a way each line contains two space-separated integers a and b, indicated that a must be fully milked before one can start milking b. And it's certainly possible for one cow to depend on more than one uh, cows to be milked before before we can commence milking of that cow. So how do we store that dependency tree? We want a quick and we want a relatively efficient way to look at the dependencies. Okay, so in particular, when a cow finishes up, we want to efficiently, preferably without looping through an entire data structure, we want to efficiently decrease the dependency count of all cows depending on it. Actually, let me label it a bit more clearly. When a cow C finishes up, we want to decrease the dependency count of all cows that depends on C. So we're going to have a notion of dependency count for each cow. And if a cow depends on 3 other cows to finish before we can start milking that cow, then it has a dependency count of 3. So for each cow, we're going to store dependency count, and every time a cow that it depends on finishes up, what we can do is decrease the dependency count of cows that depends on it. Okay. So what would be a good data structure for that? So how about I do just different ways of doing it. I can use a map of that maps a number to a list. I'm going to do something like this. Okay. So here, what I'm doing is, so dependencies of I denotes a list of all cows that are dependent on cow I. And I want to set it up like that. It does look a bit strange, right? Because an array of array list, that's really strange. But I need to do it because for each cow, there could be a variable number of cows that depend on it, and I just don't know how many there are. So better use an array list, an array of array list here. You can also do a hash map that maps cow I to a list of cows that depend on I. That also works either way. All right. With an array list, with an array of array lists, keep in mind that when you create an array of array lists like that, by default, all values are null. So let's initialize those first. So I'm going to say dependencies of I equals new array list of integer. All right, so afterwards, let's go ahead and parse the other m inputs. Right, so for the m rows, we have int a equals in dot next int, and int b equals in dot next int.
Why did you create a new array list when you just created one before?
I'm creating an array list. Before I didn't create an array list, I created an array of array lists.
Oh, okay.
All right, and so it says A must be fully milked before one can start milking B. So I believe I would have to do dependencies of A, right, which returns me an array list, and I'm going to do dot add on it B, right? Yep. Okay, so we're almost out of time. We didn't get to the meat of the, we didn't even get to the fun part. So what I want to do after I set all this up is I want to simulate time from t equal to 0 all the way to the last time step at which all cows are done being milked. Now, I don't want to be like set int t to 0 and then set t to 1, t to 2, t to 3, t to 4, t to 5, t to 6, t to 7. I can't do that because there's no constraint. Oh, actually, is there? Oh, there is a constraint for the time of each cow, but it's 100,000. And uh, if you imagine that cow 1 depends on cow 2, and cow 2 depends on cow 3, and cow 3 depends on cow 4, and cow 4 depends on cow 5. If it's like a perfectly linear dependency, there's a total of n cows. So if we do it that way, that's going to take too slow. So we can't simulate the time steps one by one that way. So what can we do? So what we can do, however, is we can store. We can create a priority queue. Priority queue of cows. Okay. And a cow is going to be represented by 2 numbers. So it's going to be a priority queue of int array. Looks kind of weird. And by the way, if you want to sort priority queue of int array, you do want to give it a comparator, because otherwise it's not going to know how to compare. So let's compare using the first value. So I'm going to do this. Have each cow be represented by an int array of length 2 where cow 0 denotes its end time, and cow of 1 denotes its ID. I haven't actually set it up so that it does that yet, but I'll leave that up to you for homework. Time is it? Shoot, I'm already 2 minutes over. So what I want to do in the priority queue is first put all cows with no dependencies into the queue. Okay. And the queue is going to be sorting those cows by the order of their end time. Why is that a good thing? Because what we can do here is remove the cow with the lowest end time. And you do that by doing queue.poll. Okay. And then here, what you want to do is decrease the dependency count of all cows that's dependent on cow C. So I'm going to call this cow C. Okay, and if any of those cows now have a dependency count of 0, add to the queue. All right. Yeah, so I'll leave it up to you to fill in the details here. So I've written the pseudocode here. So you can kind of see like why we need a priority queue here. We're iterating through the cows and we're prioritizing them based on what their end time is. So we loop to the cow with the lowest end time first, and as we remove that from the queue, right? So the queue in a way is simulating uh, it's simulating storing the set of cows being milked at the moment. Right, so you jump to, when you do queue.poll, right, you're removing the cow with the lowest end time. So you're simulating t or time, right, to that particular end time, and then you change the dependency count, right, and then for any cows that have a dependency count of 0, you add it onto the queue and iterate through that process. So yeah, let's finish this for homework. Sorry for going over. Any questions before we go?
So we need to, I just want to confirm, we need to take the, use the priority queue and say that each time we find a cow where the next cow uses the next cow is dependent on the cow before it. Once we finish that cow, we can move to the next one, and we have to use a priority queue to add stuff into it.
When a cow finishes, we have to mark any cow that depends on that cow as having one less dependent. And if those cows no longer have any dependents, then we put them in the priority queue.
Oh, I see. Okay, that's where
Yep.
it comes in. Okay.
Yep.
Wait, what about cows that are like say that cow 7 depends on cow 6, which depends on cow 5?
Mm-hmm.
How do you like take care of that?
So cow 7 is going to be put into the priority queue first. Okay. And when cow 7 finishes, then we would mark cal6 as having no dependencies, and cal6 will be put into the priority queue. And when you put it in the priority queue, remember it's an int array with 2 elements. So you need to put in the cal ID and the end time of that cal. You need to calculate the end time. Like, what is your current time right now? Your current time right now is the time when cal7 just finished, right? And you know the duration of cal6, so with that you can calculate what the end time of cal6 is. Yep. So you need to put that in as part of the array representing the cal into the priority queue. All right. Alrighty. See y'all tomorrow.
Chiba.
Thank you.
Yeah. No problem. Yes.
So I sent you my homework in an email. I just wanted to see if it was basically what was to work, like the same idea as the regular homework, because there's a problem with my syntax. I'm not sure which functions I should use in it because of the errors it's giving me, so I can't really check it. But I think what's matching on that. I mean, you don't have to do it right now, but like because you have to go to class right now. Yeah, but like I'm saying, like when you are free, I just wanted to see if that would work. I think I checked it based on. Like,
I'll take a look tonight. Yep.
Okay, thank you. Yeah.
Yep, no problem.
Well, not even tonight, but just whenever you can. That's fine.
Yeah. Yep.
Of course.
I'll get to that. All right.
Definitely. Okay, thank you so much.
Okay, no problem. Take care.